will say that our business is stronger than it has ever been.
The success of growth and where I see companies growing consistently really is your people.
I mean, the story is not, does it make power? Because they all make power. The story is, what does it power?
This is what solar installers need to know with your host, Hervé Billier and Joe Marhamati.
Hi there, it's Hervé and Joe with what solar installers need to know, where we interview solar CEOs and experts on how they run their business on the solar coaster. We ask their private revenue numbers, we give actionable advice, and learn about trade secrets so you can run and grow your solar business. Joe and I built a solar company from 0 to 12 million in sales and got successfully acquired. If you'd like to do the same or do better, go to sungro.com/blog to get actionable behind-the-scenes lessons on running and growing your solar business. And now, without further ado, let's jump right into the next episode. Welcome for another podcast episode with what solar installers need to know. And I have the pleasure to invite Nathan Charles. Nathan, you're the principal field application engineer with Enphase. So tell us more. What does that mean?
Yeah, that's a great question. So I've been with Enphase now for 10 years, which is probably better measured in dog years at this point. I've seen a lot of changes with the engineering system and the industry. But I think practically speaking, what I do is I sit between our products, our research, and customers. So I try and sit there and basically make sure that our customer voice is represented when we're developing and researching products, as well as, kind of handle escalations when weird and unusual problems get in the field. So do a lot of pre-sales support. And at the end of the day, I'm kind of a glorified fixer technically to make sure our systems are working great in the field.
Are we all trying to fix our planet and our society and all of that? We all glorified fixers, I guess. But kudos, I think of all the companies and vendors that I worked with, I think Enphase, to my knowledge, has been the only one asking me not once but several times to come to a roundtable with Badri, the CEO, directly. Enphase is not a small company, and I'm sure Badri had other things on his mind. Now, listening to his customers, although Enphase real customers more distributors, I suppose, but that the installers, we really had a voice. I really felt listened to, and more than once I was in a roundtable that was usually very friendly, but a few times it was very direct about what worked or didn't work, and he also invited me to that part. So thank you for doing that. It's splendid.
Absolutely. Yeah, I think one of the things I love about Enphase is our priority on customer service. I think we care about great products, but customer service is very high priority. So I think that demonstrates the value of kind of listening to our customers and trying to react to their needs in a timely fashion.
It's easily said, right? It's not easily done. For solar installers, listening to their customers is speaking to homeowners, which is a lot of times going straight to a sales call, or listening when there are problems. For me at Sunvoy, it's a software company, so I'm calling every Friday. I actually have an hour blocked on my calendar to call clients of mine and just listening about what's happening. Many times it turns into like, oh, we have this feature out or that feature out, which brings me to the question, Nathan, like when you listen to installers, they probably have a lot of requests. So how do you make sense of what's important, what's not? Going on a commercial, for example, it's been years that Enphase is stepping and kind of dipping its toe into the commercial space. So how do you make sense of what's important to do right away compared to like a long roadmap about like, let's get into commercial? So how do you manage that?
Yeah, that's a great question. So I kind of think about it across three horizons. What we can do like now, which is very tactical, versus what is more of like a 12 to 24, 36 month horizon, and then what's 36 beyond. So thinking about like productization, anything that's kind of in that now to 12 months, that's something we need to solve from an applications perspective. Anything that's from a 12 to 26, 12 to 24 month horizon, that's more of a product. And anything beyond 24 months is more of a technology. So if we think about moving forward 5 years, what is the market? Obviously it's very uncertain, and you have externalities like tariffs and policy changes that can dramatically change things very, very quickly. But if you think forward 5 years and look at the landscape and then work backward from that, then I think that's kind of like where you start to set your priorities. And obviously from a sales and applications perspective, we're very much focused on tactically what can we accomplish now with our current set of products and features.
Now, Enphase is a publicly traded company, so you have shareholders, you need to provide value, and at the same time you think long term. I remember the moment where Enphase bought like that EV manufacturer, Clipper Creek, yeah. So making those bets are kind of I mean, in hindsight, it was a beautiful, beautiful piece. But so, what's going on in your world? Would you see some trends that you can talk about, that you can share about what you think is happening in the foreseeable future?
Yeah, absolutely. And the EVSE conversation is very appropriate, right? Because if you think about EVSE, I would say like I think the question was, what do solar installers need to know? And I think the reality is we're no longer just solar installers, right? Increasingly, we need to think about financial products and how we finance these things, as well as how does solar interact with the other loads and essentially priorities of the customer. So as we look at the US market compared to some of the other markets, even within the United States, we're seeing kind of a couple different trends, I think. The first, if you look at California as one example, we're seeing battery attach. So it's not just solar, it's solar and storage. And the Clipper Creek acquisition, as you point out, really is addressing probably the next biggest load, which is EVSE. So if I think about from the residential perspective, what are your biggest loads? Typically, it's going to be your hot water heater, your HVAC system, and then your EVSE. By entering the EVSE space, that gives us green charging. And then as manufacturers start to extend their technology in terms of bidirectional capabilities, well, then we can bring that asset into the overall home ecosystem in terms of energy management. We obviously another product acquisition we made was GreenCom from Europe, and that's recognizing that HEMS home energy management systems is very much a part of kind of that trend beyond just basic solar install. So, you think about controlling EVSE, solar and storage, and then also as we move forward, HVAC systems and also kind of water heaters and things. So those are some of the residential trends I see in the United States. You're no longer just a solar or installer. And I think a lot of the codes and standards and market trends are kind of reflecting that.
Yeah, maybe it's time for us to think about the name of the podcast, like what solar installers need to know. We've struggled with this because we say solar installer, we don't say battery installer. You're not really an energy management company or be part of the energy transition, because you have energy providers, you have brokers, you have all types of energy consultants already. So I'm still failing to put a good name on what we historically have been calling a solar installer. So you're not really an EV installer either. Even electricians kind of do it on the side. Solar installers also do EV, but it's not just the only thing they do. So maybe we should come up with a better term than solar installer.
Yeah, well, it's we're about delivering energy and power solutions. So I mean, it's Enphase energy, right? And energy reflects both solar as well as storage and EVSE and a lot of other things as well.
All right, let's speak about like the commercial trend that's happening. So tell us more.
Yeah, absolutely. So we're pretty excited to finally have a true 277 480 volt product. Obviously, we dabbled with this in the past with kind of the C250 line, but we now have a native 277 480 volt product that we're bringing to the market with the IQ9 platform. So we're really excited about this platform, essentially using GaN, and GaN obviously gives us a lot of benefits. So our microinverters in the past used silicon for the powertrain, and with IQ9, we're now moving to GaN. So GaN does a lot of different things for us. It switches harder and faster, more efficient, and as well as more reliable. So every generation of a microinverter has increased our overall reliability profile, and we expect that the IQ9 will continue that. And it also gives us access to the 277 volt market, which is very exciting.
Tell us more about what it took to go from an idea like let's look outside of the silicon technology and look at GaN. How long did it take for you guys to go from the idea to testing to building it out to then commercialize it? Because there's also a lot of risk involved. Like it has to work. Still, a lot of people would think like, well, why put a little computer behind the solar panel, baking in the summer and being in the freezing cold in the winter. Most computers won't be able to last very long. So now you have to do the same again, the different technology. So how long did it take?
Yeah, that's a great question. It's hard to put an actual timeline on that, but if you think about it, kind of as looking at the technology. Obviously, we're talking to technology folks, years in advance of actually productizing things. But in terms of how long has GaN been available, practically productized, in a cost-effective fashion. You think about, just because you have an idea doesn't mean that the products are available to actually commercialize something. So it ends up can be a very long timeline. It's actually from the time you have a concept through actually, like I said, not just proof of concept, but productization, and then like going through reliability and actually delivering the product. So it's been longer than we'd probably like to admit. If you think about, I've been with Enphase for over 10 years now. And if you think about, we were dabbling in 27740 and wanted to get to that, 10 years ago, I think it's probably fair to say that, we've been thinking about it the entire time.
Yeah, we installed some 100, 200 kilowatt projects with one of your early commercially available CT2 versions. Still working great.
Glad to hear it.
Well, talking about like working in the field, what are some major gaps you see between the technology, between like what's working in labs and what you see actually happening? Because you have an overview of what every installer does out there. So what are some gaps that you wish people knew better about how to do better, what to avoid, and any advice?
Yeah, it's a great question. I think I'll answer that two ways. One is, I think, interoperability and compatibility, and the other is essentially kind of where code compliance and standards are going. So there's always just a little bit of a challenge of when a standard is adopted or a code is adopted versus the technology that actually enables it. So if you look at kind of where the National Electric Code is going, it was, how long ago now was it that we ended at rapid shutdown was added to the code cycle? And I think it was 2014 was rapid shutdown was added. So then you think about like the technology of rapid shutdown and the standards where that goes. But I think
Can I add something about rapid shutdown? Why is that so important? But I'm an experiential learner, so to speak. My mother in Europe, I tried to convince her for years to go solar, and she finally did it, had an SMA installed by kind of a local electrician that does solar kind of like a little bit on the side. And she has like a kind of a build-up shed, like a fancy place. She put solar in that shed, and she saw some smoke. So she goes in, and one of the wires got like one of a clamp, like not a good connection. It was next to a cardboard box, so not in a conduit either, and that box started burning. And she explained like lots of arcing. And what did my mom do? She just took those two wires and ripped them apart. But basically, that explained it, that to shut down once you have DC, once you have arcing and the sun is shining, besides asking for the cloud to go by or the sun to go down, it's just gonna keep arcing. There is no other method. Like because you're turning the disconnect off is not gonna shut that circuit, right? So the only way is to have a rapid shutdown on that panel. Otherwise, it will just keep arcing. So I learned that in a practical hard way, so to speak.
Yeah, and yeah, absolutely. And I think my argument continues to be like, low voltage DC is the safest. And from a reliability perspective, having essentially a microinverter with your panel, that DC, and that's the highest reliability and safest solution. And that's, one of the reasons why we think even with a premium, we probably can play in the commercial space, just because we think it is the most safe and reliable way to generate power and energy. But in terms of going back to the conversation about like the codes and standards, well, rapid shutdown was one. And then as we think about interoperability, IEEE 1547 introduced the concept of interoperability. And then the National Electric Code introduced the concept of power control systems. So increasingly, I think the trend is silicon, not copper. We're using silicon and intelligence instead of just adding a lot of copper and dumb stuff. So if you looked at the trajectory of microinverters, essentially we're displacing copper into silicon. Power control systems is the way that's going. And if we look at where the National Electric Code is going in the 2026 code cycle, power control systems is no longer in Article 750.
Mm-hmm.
It's now Article 130. So it's front and center. Sizing moved from Article 220 to Article 120. So sizing and power control systems are now front and center in the 2026 code. And as obviously there's education around these things, but essentially we see the codes and standards moving toward interoperability and using silicon as part of the way we interconnect and control systems. Practically, what that means is that things that were like for example, before Enphase had a grid forming battery solution, we would see folks AC couple with third-party systems. And, Enphase would be just, AC coupled, a grid interactive inverter running in interactive mode against a grid forming battery. That was, for a lot of folks, that ended up working really, really well. But when you start to do system expansions, and now you need PCS features, it becomes much more challenging to kind of plan those expansions when you have heterogeneous configurations that don't necessarily have power control systems interoperability. And where I see essentially this going, particularly in the residential space, is increasingly I'm seeing requests for, like, for example, multi-mode certification under UL 1741 at a system level and not just a component level. So I think there's some practical implications, if you're going to do interoperability and kind of heterogeneous systems, it may be more challenging in the future. So thinking about like what ecosystem are you really investing in and participating in as you kind of grow your business.
You mentioned multi-mode certification. I don't know what that is.
Yeah. So the 1741 historically has been, about interconnected power production sources. And for most of us, for a lot of years, we focused purely on the interactive component of that. But there's also the grid forming and standalone component of this. Multimode is kind of the transition between the two. So you can go from interactive to grid forming. You're changing your mode. So it's a multi-mode. And there's two ways to do that. An open transition where it's not seamless and a closed transition where it's seamless. And increasingly, I'm seeing utilities start to focus on around this system level multi-mode certification. That's kind of a CRD certifying requirements document. That's a supplement to the actual standard. As utilities get more sophisticated and understand kind of some of the gaps from a system perspective, they're starting to look at certifying these things and getting kind of validation around behavior. So a couple other standards that kind of reflect this, like I mentioned 3141, which is power control systems, UL 3141. There's also a new standard, UL 3001, which is distributed energy systems. So again, moving beyond just the base power production sources, we're now thinking about systems. Again, we're moving from components that are just heterogeneous and may or may not play together well to interoperability in IEEE 1547, and then moving towards systems in UL 3001. Thinking about where not just what you need or installing today, but kind of what you will potentially be integrating and installing in the future is definitely something we need to increasingly be thinking about.
I remember a very nice speech about like we're not solar installers anymore. We are part of the energy transition. We are providing a source of energy. That comes also with reliability and everything that goes after that. I want to ask just go switch a little bit about customer experience and data. So you mentioned that more silicon, less copper. I like that. Put it like that. But if you have a lot of data coming in at Enphase level, how do you make it useful for the homeowner, the installer? Just so much raw data is not making anything necessarily useful. So what do you see people want to know and how do they want to use it in the future?
Yeah, that's a great question. And I've heard a lot of different perspectives of this. And, there's the things that I want to know, and then there's the things that other people, want to know or maybe don't want to know. And I think to me, it's really about providing actionable insights. If there's not something I need to take action on, I don't want to pay attention to it. But if there's a problem, I want to know about it. And then I want to have sufficient data to basically clearly diagnose and take action on to resolve the problem correctly. I think this is still something we're working to. And I think the other backdrop trend, kind of the power and energy industries, data centers and AI. I think we're doing a lot of work with artificial intelligence to basically start to sift through and start to, take action and resolve issues even before customers know about them. CT errors, for example, is one problem that I've been fighting with now for over 10 years. And if you give an installer a CT, there's a myriad ways that they can, or I can install that incorrectly. I've definitely installed them incorrectly myself. I think the reality is like CTs are fundamentally challenging, and I think there's no shame in installing them incorrectly.
Yeah, but we calculated once how many different ways you can do. I think it was 27. I think something like that.
I've stopped counting. In 2016, I think I made a list of, I said a first principles. It's like, I think there's 9 ways to get it installed correctly. Then installers continue to surprise me with new and creative ways to mess them up. So my list is now over 50.
All right.
And I've stopped counting. It's challenging. And again, like where I was going with this is that, for certain CT errors, we now can recognize and correct that remotely in just based upon the telemetry signals. And that's where we would expect to see artificial intelligence, either shallow or deep machine learning, give us ways in bringing kind of energy data and forecasted solar production into the mix. And we're starting to see this with kind of AI optimization around kind of scheduled dispatch, particularly as we start to see more dynamic tariffs and virtual power plants come to bear. So I think that there's a lot of interesting trends here back to this. You're not just a solar installer anymore, and you're part of the energy transition. And essentially there's there's the assets that you're installing as well as the control you're bringing to bear on the problem to provide value to our customers.
Yeah, VPP is definitely one of them. I guess it's more silicon, and you still need the copper, but clearly there's more going on there. Now, does the AI that you are working on is more like informational, or does it also take actual action, like flip the CTs, like the AI identifies it is an easy case, and then actually flip it for you? Is it going that far?
Yeah, so the CTs are being flipped. Basically that's essentially taking action.
Mm-hmm.
And then again, in the case of the VP, like the optimization, particularly for California, where we are seeing like dynamic rates take place, then we're scheduling storage in advance, solar and storage in advance to basically optimize the customer's payback. So these are examples where the AI has artificial intelligence is actually taking advantage. It's kind of funny because just as a sort of sidebar here, like AI, in the solar world, it's sort of ambiguous because for me, AI was always anti-islanding, and now I have to clarify whether in the same conversation internally, whether I'm talking about anti-islanding or artificial intelligence.
See, that's a funny one, yeah. So the VPP is also being expanded, you understand, at the Enphase level. Is this only in the US, or do you learn from places in Europe and kind of bring that knowledge back to the US, or is it going the other way?
Absolutely. And, obviously like where things are going in Europe with dynamic tariffs and, negative pricing, we're definitely starting to run some of those algorithms in Europe as well. And the Europe market is definitely a very interesting one as well. So when we continue to try and expand and grow internationally, obviously we've been in Europe for a long time, launching increasingly, doing geo expansion in other markets as well. So it's definitely bringing those VPP offerings where they make sense to other markets is definitely happening.
We spoke about silicon to copper. Let's speak about something very practical that I think I would love as an installer. So tell us more when installers can start using them in the field, because in the middle of COVID, we reached out to all local utilities, like we cannot go into the house, we want to keep installing, we can do everything outside, if only we could use those colors. And at that time, utilities said like, nope, don't care, still not approved. There's definitely some pushback there.
Yeah, and for folks that, maybe you're not up to speed on this, obviously we're now on our 4th generation of grid forming batteries, with the IQ battery 10C.
Mm-hmm.
And Liner 6 and the meter collar, which is our kind of distributed microgrid interconnect device solution. And I'm really excited about this because I think it gives us the right levers. Obviously when you put the MID behind the utility meter, the utility has opinions about that installation experience. So we need to work very closely with our utility partners to get approval to make sure that can be installed. At this point, we do maintain a list of all the utilities we do have approval with. I think at this point, we're one of, if not the largest, we have the largest service territory in terms of meter collar approvals. So, more than 50 utilities that we've got approvals with across the United States sit in the Mid-Atlantic region and the Mid-Atlantic and Northeast. A lot of the approval processes are a little longer than some of the other states, but we see this as being a trend. Connecticut, for example, the Public Utility Commission basically made a ruling that the utilities should adopt meters. Essentially there was a process that was created around that. Massachusetts passed a law around meter socket adapters, and that they need to be applied. We're in the process working through the technical standard working group up in Massachusetts to be part of that meter socket approval process. We're starting to see it, pop up in different New Jersey, Maryland. So obviously there's a couple different ways that meter socket adapters, which is the IQ meter collar is one of, gets approved. We're actively engaged with a lot of different utilities, and hopefully it'll come soon to a utility near you.
It has a massive impact on installations.
Absolutely.
I can tell you that. Like, you don't have to go as much inside the house. I remember installing myself. Like, you go inside the house, there was a cat, or so the customers there. Some customers don't talk to you, but others, they love to talk. So every time you walk in the house, another conversation starts, which is lovely, but extends your installation time. So you don't want to say no to people either. So just going out, staying outside and doing that, massive impact. Cost of installation.
Yeah, well, absolutely. I mean, even if, obviously in California, it was actually absolutely critical because you have meter main distribution combos, and there is no practical way to intercept the existing loads without essentially doing a full load relocation. In the East Coast, we typically do meter main disconnects for meters and then essentially separate disconnects. So it's easier to intercept the, kind of the loads. But even when you can intercept the loads, you still need to rework grounding and bonding. The meter main, when you can basically use a meter socket, it prevents you from having to not just intercept the loads, but also rework grounding and bonding. And as you point out, that's a huge labor saving. The other great thing about the combiner, though, combiner 6, it's a place to capture both solar, storage, EVSE, and then also load control. So back to the conversation about where things are going from a standards perspective, and what solar and storage and all the folks participating in the energy transition need to know. The 2026 code cycle kind of puts a nail in the coffin of the largest single load sizing under 710. For a lot of us, we always sized the backup component based upon the largest single load. And as long as the battery exceeded the rating of the largest single load, we were good to go. We didn't need to do a lot of code calcs or anything beyond that. In the 2023 code cycle, that was weakened, and then in the 2026, it's clarified that the backup sizing is kind of moved under 702 under optional standby systems, and you can no longer charge for the largest load. But if you're automatically connecting loads, you either need to handle everything or add load control, or basically not restart. So there is an exception for multi-mode inverters. If you've been certified, you can basically not restart and basically then still size under the largest single load. So the practical implication of that is that if you're doing a DC coupled system where you don't have load control, well, practically speaking, you may be undersized under the 2026 code cycle for backup. The beautiful thing about IQ8 microinverters and IQ9 as well is that from a power capacity perspective, the microinverters are grid forming. So it's not just the standalone supply is not just the batteries, it's always also the solar. And with the IQ Combiner 6, we also bring in load control to the mix. So that means that with kind of the Combiner 6, you have very quickly, more than 100 amps of continuous backup capability. As well as load control. Between the load control and the load control and essentially the continuous rating, of all your DERs, you can very easily back up a 200 amp service. And that will be more challenging under the 2026 code cycle. Clearly, the possibility for overload was never great, but was always safe. And the NEC at the end of the day is not a performance document, but rather a safety document. But I think they're kind of moving it into saying, like, while it's maybe safe, it's a bad experience to have your microgrid collapse, and we want to make sure that we're sizing systems correctly.
Yeah. Well, one more piece about safety: you can avoid line side that.
Yeah, it's a great point. And some jurisdictions have never allowed line side or supply side connections. As you point out, power control systems allows us to. That started in the 2023 code cycle. No, 2020 code cycle, where we introduced the ability to do, rather than the 120% rule, as long as we were measuring and controlling all the current on the bus bar, we could basically match the rating of the bus bar. So we do have, even with our grid interactive systems that don't include backup, we can basically go beyond the 120% rule and put much larger systems backfed via breaker into the main panel with that UL3141 functionality, power control systems functionality.
Good. Well, Nathan, thank you very much for sharing your knowledge, your experience. Thank you for your 10 years in the series in solar. Actually, more than 10 years. You were already in the solar industry before 10 years at Enphase. Thank you, Nathan. It's been a pleasure talking to you.
Absolutely. Great talking to you, Hervé. Talk to you later.
Thank you.
If you'd like to do the same or do better, go to sunvoy.com/blog and get actionable behind-the-scenes lessons on running and growing your solar business.